equation we are given an inequality. It says that modulus of x square plus 3x minus 1 is less than 2 times modulus of x plus 5, and we are required to calculate the number of integral values of x which satisfy this inequality. If you are looking at the inequality, we have to first figure out what are the signs of modulus of x square plus 3x minus 1. That is, for what values of x is it negative, and for what values of x is the expression inside the modulus positive. Essentially, whenever you are looking at a modulus, you have to figure out what are the inflection points. That is, at which the sign of the expression inside the modulus changes. For the right hand side, it is quite simple. We have only 2 times modulus of x plus 5. So whenever x is less than 0, this becomes equal to minus x, and whenever x is greater than 0, it becomes equal to x. So there is no confusion there. The only confusion is with respect to the quadratic equation. So when is it less than 0 and when is it greater than 0? If you have a quadratic equation and if you find out that the roots of the quadratic equation are a and b, so the quadratic equation is essentially equal to x minus a into x minus b. This quadratic equation is greater than 0 if x is greater than b or if x is less than a. That is, whenever we are assuming that a is less than b and these are the two roots, and if you draw the number line, this is a and this is b, whenever x is to the left of a, the expression will be positive. Whenever x is to the right of b, again the expression will be positive. The expression will be negative only in the middle. Whenever it is falling between both the roots, then it will be negative. So the first thing we should do is try to identify the roots of the quadratic equation x square plus 3x minus 1. We can use the formula for solving the quadratic equations. If you have a quadratic equation which is of the form ax square plus bx plus c is equal to 0, the two roots are minus b plus or minus square root of b square minus 4ac divided by 2a. In this particular case, the two roots of x square plus 3x minus 1 is equal to 0. They will be minus 3 plus or minus square root of 3 square is 9. Minus of minus 1 will become equal to 1 into 4 is plus 4 divided by 2. So the two roots are minus 3 minus square root of 13 by 2. And the second one is minus 3 plus square root of 13 by 2. The approximate value of square root of 13 you can calculate will be 3.6. So the approximate value of the two roots is minus 3 minus 3.6, that is minus 6.6 by 2, and minus 3 plus 3.6, so this is 0.6 by 2. So the two roots will be minus 3.3 and 0.3. Once we know this, let me clear the board so that we can again start from afresh. So the two roots of the given quadratic equation are minus 3.3 and 0.3. These are the two roots. We are only looking at integer values. So you can divide the entire number system, if your number line, if you are looking at the inflection points, into three parts. The first part will be when x is less than or equal to minus 4. The second one is when it is between minus 3 to 0. The third one is when it is from 0 to infinity, or basically from 1 to infinity. Remember, we are doing this only because we are only looking at the integral values. Otherwise, we have to divide this into a lot more parts, because we will have to look at 3.3 and we have to look at 0.3 and 0 separately. And if you are looking at the expression, this quadratic equation as say a, and if you are looking at x value as b, whenever x is lying between minus infinity to minus 4, a will be greater than 0. That is, the quadratic equation will be greater than 0 because x is not lying between the two roots. And b, that is the value of x, will be less than 0. In the second case, when x is lying between minus 3 to 0, the quadratic equation will be less than 0 because the value of x is lying between both the roots, and b also will be less than 0 because x itself is less than 0 and the value of b is x. In the third case, where x lies between 1 to infinity, the quadratic equation will be greater than 0 and the value of x also is greater than 0. Now that we know it, let us try to solve the given inequality. In the first case, the inequality will look like this: x square plus 3x minus 1 is less than minus 2x plus 5. This becomes equal to x square plus 5x minus 6 is less than 0, or x plus 6 into x minus 1 is less than 0. So the value of x has to lie between both the roots. The two roots are minus 6 to 1. So the value of x can be either minus 5 or minus 4 or minus 3 or minus 2 or minus 1 or 0 or 1. But in this particular case, we are only looking for x less than or equal to minus 4. So all of these are not needed. The only two numbers which lie in this interval which satisfy the given inequality is minus 5 and minus 4. If you are looking at the second case, where x lies between minus 3 and 0, both of them included, then both the quadratic equation is negative and x is negative. So the given inequality will become equal to minus x square minus 3x plus 1 is less than minus 2x plus 5. This would become equal to x square plus x plus 4 is greater than 0. This is always true because x square plus x plus 4 can be written as x plus 1 by 2 whole square plus 4 minus 1 by 4 will become equal to 15 by 4. This is always greater than 0. So all the numbers which lie within this interval will satisfy the given inequality. So they are minus 3, minus 2, minus 1 and 0. All of them will satisfy the given inequality. If you are looking at the last interval where x lies between 1 to infinity, 1 included and infinity obviously will be open bracket. Then both of them are positive. So the given inequality will become equal to x square plus 3x minus 1 is less than 2x plus 5. This would become equal to x square plus x minus 6 is less than 0. So this will become equal to x square plus x minus 6 is equal to 0. So this is equal to x plus 3 into x minus 2 is less than 0. For this to happen, the value of x has to lie between both the roots, which is minus 3 and 2. So x has to be either minus 3 or minus 2 or minus 1 or 0 or 1. 2 is not included because this is a strict less than sign. In fact, minus 3 also is not included because this is a strict negative sign. There is no less than or equal to. But amongst these four roots, minus 2, minus 1, 0 and 1, we are only looking at the roots which lie between 1 and infinity, 1 included. So all these three can be ignored. So we have one root over here in this interval which will satisfy the given inequality. So the total number of integral values of x which satisfy the given inequality is 1, 2, 3, 4, 5, 6 and 7.